Hello everyone, my name is Aishriza and today I will be presenting CyberConnect, a web application I developed as a social networking platform for cybersecurity enthusiasts. This platform is designed to create a collaborative community for students, professionals and cybersecurity enthusiasts by providing a space to share threat intelligence, CTF write-ups, cybersecurity news, security tips and technical discussion, while enabling users to connect with others who share similar interests. This project was developed as part of the coursework requirement for the Internet and Web Technologies model. Let's begin by taking a look at the application and exploring its key features. Before diving into the features, let me walk you through the system architecture. This is the project structure in VS Code. The application follows a modular Flask architecture. The root directory is organized into separate modules starting with init.py, which initialize the route package. Next is admin.py for administrative function, followed by auth.py. Auth.py is for user authentication and authorization, while connection.py manages user connection and networking features. Notification.py handles user notification. Post.py manages post creation and interactions. And now profile.py is responsible for user profile management. Moving on to the project structure. App.py serves as the main entry point for the application, where the Flask app is installed and all routes are registered. The application data is stored in the connection.db SQL-like database, while db.py manages the database connection and configuration. The module.py file determines the database modules and relationship, and form.py contains the Flask WTF implementation in utensils.py to improve code reusability. The template directory store all Jinga 2 HTML templates responsible for rendering the user interface, while the static directory contains CSS, JavaScript, images, icon, and other static assets. Finally, requirements.txt lists the project Python dependency, and render.yml provides the deployment configuration for hosting the application on the render platform. I follow the modular structure. Each route blueprint handles a specific domain. The module file acts as the data access layer, interacting directly with MySQL using parameterized queries. The separation of concern makes the code maintainable and scalable. This function in models.py use parameterized queries to prevent SQL injection. Now, let me demonstrate the registration flow. I will create a new user. After logging, the username and profile image are displayed in the sidebar. Logout clears the session completely using session clear. Here's the database function that saves the post. Clicking the light button sends the AJAX request to the server. The server toggles the like in the database and returns the new count, all without reloading the page, like this. Security was a top priority in this project. Let me walk you through the key security measures. The application configuration is defined in app.py. Environment variables such as secret key and MySQL credentials are loaded using the Python.NET library. The database connection is installed through db.py, ensuring the sensitive configuration values remain outside the source code. Sensitive data is located from the .env file, keeping the secret key and database credentials out of the code base. Decrypt is a slow hashing algorithm designed to resist brute force attacks such as includes a random salt. All database queries in modules.py use parameterized queries with placeholder. User input is never directly involved in the SQL strings. Jinga to auto escape all output. This prevents script injection attacks. Only image file types are accepted. I check the file extension before saving. I use Git for the version control from the beginning. The repository is hosted on the GitHub. Here is the commit history. Each commit has a clear describing message following the conversational commits format. The first manual test case verifies the user registration functionality. First, the user enters the valid full name. Next, the user provides a unique email address. Then the user enters a secure password. After completing the registration form, the user clicks the create account button. The system successfully creates the account, displays the confirmation message, and automatically redirects the user to the login page. Since the actual system behavior matches the expected outcome, this test case is marked as a pass, confirming that the user registration functionality works correctly. The next test case verifies the user login functionality. First, the user enters the registered email address. Next, the user enters the correct password associated with the account. The user then clicks the sign in button to submit the login request. The system verifies the user credentials by comparing the entered password in the securely stored decrypted hash in the database. After successful authentication, the user is redirected to the CyberConnect dashboard where the personalized information such as username, post connection skills is displayed. Since the actual behavior matches the expected outcome, this test case is marked as pass, confirming that the login functionality is operating successfully. The next test case verifies the post creation functionality, which is one of the core features of CyberConnect. First, the user enters the post content in the text area to share cybersecurity knowledge, CTF write-ups, or security tips. An image can also be attached to the post. This step is optional and allows user to include supporting visuals. After completing the post, the user clicks the publish button. The system processes the request and stores the post in MySQL database. The newly created post is immediately displayed in the news feed together with the author's name, timestamp, and post content. If an image is included, it is displayed correctly with the post. User can then interact with the published post using the like, comment, and share feature. The expected result was that the post should be published successfully and become visible in the feed. Since the actual system behavior matches the expected result, this test case is marked as a pass. The final authentication test verifies the user logout functionality. The user clicks the sign out button from the navigation menu. The application clears the user's active session, security logs, and the user out displays a confirmation message and redirects the user back to the landing page. The expected result was the user session would be terminated and access to be protected page would no longer be available. Since the actual behavior match the expected results, this test case is marked as the pass. Let me show you the application running in my local development server. As you can see, CyberConnect features a modern dark theme interference inspired by cybersecurity aesthetic. The design combines a clean layout with a professional look, making the platform both visually engaging and easy to navigate for students, professionals, and cybersecurity enthusiasts. In conclusion, CyberConnect is a complete web application that demonstrates user and session management, secure registration logging without a backcrypt password hashing, a robust backend, Flask API with MySQL, proper database design and modular routes, professional grade UI, dark theme responsive design, consist styling across all pages, multi-layer security, SQL injection prevention, XLS protection, session security file verification and password hashing, AJAX interaction, like, comment, share, follow without page refresh or smooth experience. Clean version control, Git with conventional commit and feature patches. The full source code is available on GitHub. This demonstration video is linked in the README and my report. Thank you for watching. I hope this video has given you a clear understanding of how CyberConnect works, from authentication to feed interaction and security. This project has been a valuable learning experience and I am proud of the result. I look forward to answering any question during Viva session. Thank you for your time again.